We're here at the 2011 SAE International Hybrid and Electric Vehicle Symposium in Anaheim, California, and we're at the Protean stand with Tom Protean. Tom is Principal Applications Engineer for North America for Protean Electric, which is a UK-based developer of electric wheel motors. Hi, Tom. Thanks for spending some time with us.
Thank you for having me.
We've been following the Protean wheel motor program for quite a while in the magazine. Could you give us kind of a status report on where development stands right now?
Oh, sure, absolutely. We have several demonstrator vehicles that we've put together to showcase our technology, one of which is in Detroit, where our headquarters is at, as well as two other vehicles in the UK and another one under development in Germany right now. And we have a lot of people looking at these vehicles with some very serious intentions. We have a very strong development roadmap as well that we're executing as we speak that will take us to production with a goal of being in production in a high volume scenario in about 1 year from now. So it's things are looking good for us with regard to the state of readiness. While we're a startup company, we've got a considerable head start on most startups, having started with a great deal of technology in the very beginning that we're leveraging to the maximum extent. So it's a relatively short path to production as this type of technology usually goes.
Now, my understanding of wheel motors, if you're looking to re-architect a vehicle, looking at electrification, wheel motors give the vehicle architects quite a bit of latitude to do things differently. Can you talk about that a little bit?
Well, sure, absolutely, and that's spot on. With regard to what I would call a clean sheet vehicle design, you look at the vehicle as we know it today, and it can be much different with wheel motor technology. The space in the center of the vehicle that's normally allocated for powertrain, engines, transmissions, drive shafts, differentials, half shafts, these things all go away with a vehicle electrified using wheel motor technology. And that space can be reallocated for passengers, cargo, or battery space, which is typically a problematic space for us in that there's never enough space for battery. So it gives you a great opportunity if you have the opportunity to design a vehicle around this architecture. Now that said, you would expect that that would be its strongest point, but in fact it turns out that the retrofit application is a stronger point yet, in that because the technology is confined to the wheel space, it's very highly conducive to retrofit applications as well. And in fact, we find most of the attention from our customers in that space because everyone is in a big hurry to electrify their vehicles, and more often than not, they want to use an existing platform to do that with, at least for the short term. And by investing in Protean technology for that short term, it gives them a pathway to that longer term clean sheet approach that is what everyone knows is the right way to do this.
It sounds like the original vehicle that Dr. Porsche designed back before the turn of the last century, which had two electric wheel motors and conventional power to the other set of wheels.
He was on the right track, and who knows where we'd be today had he not been derailed with that track. But we all know the story that de-emphasized the use of electric technology back then. Strangely, they had the same problem we do today with batteries, but we've come a little ways since then, so maybe this time is right for wheel motors.
Now, you had mentioned that Protean has a number of demonstration vehicles out there that OEMs and the industry are looking at. What are some of the development challenges you guys are working on at this point?
Well, the biggest challenge that we have is what I would say one of perception, and we hear that a lot in this business. But in this case, there's a perception that adding mass to the wheel of a vehicle is something that's just highly negative. It's the bad thing to do. Well, our challenge is to turn that from what is arguably borderline superstition to a science that allows you to do a proper sizing of the motor for the vehicle application. Namely, that the unsprung mass problem, that is what we do with a wheel motor, isn't as big of a problem as everyone thinks it is, because it's not the mass itself, it's the ratio of unsprung mass to sprung mass. So if you size the motor correctly for the application and you deploy normal engineering practices for tuning the suspension after you've done this, it isn't the problem that everyone perceives it to be. So if we can get through that, I think we'll have a clear path to a very satisfactory outcome. And so we're spending a lot of resources on that right now and trying to dispel the myths that are surrounding this unsprung mass problem. There's other obvious problems that people would put maybe higher in priority, but we've solved those. One of sealing. Everyone worries about ingress of moisture and dirt, and we've done a pretty good job in sealing, and we have a path to a much better sealing process yet. And even the motor in the stage that it's in right now is adequate for the demonstrator fleets and for prototypes, and it serves the purpose well with even this preliminary approach that we have in place right now, such that we have had no failures due to moisture ingress at this point, at least that I'm aware of. And if there were some, it was well before the current design of the motor, which is about a year old now. So sealing is one that people expect to be a big problem that we don't see as such a big problem.
Because you've got your power electronics inside this hub. It's a very integrated, design-integrated structure.
That's correct. That's correct. So another problem that people perceive that has proven, again, not to be the problem they think it is the fact that since we put the power electronics in the motor, they expect that that is the frail part, and it's going to see all the shock and vibration of the road, where in fact the approach that we've taken has immunized us from that. Because the componentry that we use is smaller in scale, it has less mass, it has less inertia in a shock and vibe scenario. So because of that, it's more robust inherently, and it is one of the key enablers that will allow wheel motor technology to prevail 100 years after it was originated.
Very interesting. How about failure mode testing for these systems as well?
Well, that's a very good point, in that very same miniaturization that was enabled by our partitioning of the inverter, this has given us a great deal of advantage in other places as well. This particular motor has 8 inverters internal to it, and because of that, you can have a failure of any single inverter and you're only going to lose 1/8 of the power, and that gives you a sense of redundancy that's going to further enable the technology, such that if you lose an inverter, it's only 1/8 and not something you're going to notice. It's not something that's going to lock the wheel up. It's not something that the other 7 can't drive through. And in fact, if you have 4 of these motors on a car, there's 32 inverters, and if you lose one, if the light didn't come on the instrument panel, you might not even notice it. There's a number of other reasons why the failure modes are reduced with this redundancy that go far beyond the short interview that we can have here, but suffice to say that we've created redundancy through the partitioning of the inverters that is going to enable us to be immune to those kinds of concerns.
I'm curious, what, say, version of the wheel motor is development at right now, and what do we expect to see, say, in the next 12 months?
Well, we do have a low volume motor as we put it now. It is relatively labor intensive, and the next generation is going to provide some automated assembly capability, some sealing improvement, as well as some improvements in power and torque. So that's a next step that we'll see in just a few months, with another big iteration ready to hit the streets in about 1 year from now. And that will be the one where we're able to go to a much higher scale, a much larger volume of production. So there's the evolutionary path. About a year from now, we'll be in widespread deployment, whereas right now, more or less limited to our small demonstration and prototype fleets that we've got out in place in the world.
Very interesting. And final question, I understand you guys are going to be presenting a paper at SAE Congress in April. What's that going to be about?
Well, we touched on the subject already with unsprung mass. We're going to present real science that is applied to this concept of the unsprung mass concern in an attempt to take it to a level where people can understand it. The stereotype of the wheel motor with its high unsprung mass is something that needs to be nipped in the bud, if you will. So we've got a number of experts that are on task as we speak to dispel the myths and the rumors and to turn it into the science that it deserves to be. So we'll be submitting a paper that we hope achieves that. But that isn't where it ends. There'll be a lot more expertise that comes into the fray shortly thereafter that will certainly pick up where that paper left off and carry it forward into something that we can use to optimize a vehicle for use with wheel motors. This is certainly beyond showing what the math is, and to turn it into something that gives you a process to a solution such that you have a vehicle that people can be satisfied with regard to ride, handling, and steering performance.
Sounds like some real valuable information for OEMs and those in the industry interested in your technology.
Well, I'm sure they're going to be ready to debate the subject, and we're going to be ready to take them on.
Very good. Tom, always good to see you. Thanks so much for your time.
Very good. I appreciate it, and thank you.
Thank you.